hang on a second. I haven't actually totally decoded this one, so I don't have much more else to say with it, but to say about it. But there you go. Anyway, there's been a few examples of bots and malware and so forth actually doing crypto correctly. For most of the web-based stuff, the only one I've really seen doing it right is LuckySploit, and it's a toolkit, and and if you remember the talk that was immediately before this one on downloading your JavaScript in little chunks, it essentially has 3 chunks or 3 stages, and the first one has a complete RSA implementation written in JavaScript, and generates a random session key that it sends back to the LuckySploit server, which then encrypts the second stage of the JavaScript, which checks all the vulnerable versions of Flash and PDF and Java and whatnot are installed on the machine, so that in the third stage it knows which exploits to send. And with the RSA code and the big code was written by by Tom Wu back in 2005. You can get the code off of Google Code. It uses Math.random for filling the random numbered pool, which is somewhat significant if you're felt like cracking the crypto. And there's actually 2 RC4 functions in it, because in the Tom Wu code there was an RC4 function used just for filling the randomness pool, and then there's a separate RC4 function that the LuckySploit author put in that does the actual crypto of the JavaScript segments. So it's been slightly modified from the Tom Wu code. It may just be based on a later version because it has this function in it. So the first thing that LuckySploit does is it generates a 53-byte session key, which is always this value, and then it throws it away. And I don't know if why it does that. It's probably like leftover debugging code or something. And then it actually generates a real, random 53-byte value. It does it in it's not quite. It's 53 bytes with a base 64 symbol set, so it's not actually the full 8 bits for each of those. But I've seen a lot of JavaScript code that generates cookies using a similar algorithm. So 53-byte value stuffed into PKCS, formatted blob, and with 8 bytes of randomness from the randomness pool, and encrypted and sent back to the server. There's a public key in the JavaScript that is used for doing the encryption. And to sort of give an example, let's say that this is your random nonce. They just randomly happen to be AAAA. And you just randomly happen to have that as your 53-byte key. So when you pack it, it goes like this. It's ASN.I, so that means that this is an integer, and that means this is a string, and so forth. You encrypt it with RSA, you get this here, and that's what's sent to the server in the URL, in the GET request. So the server sends back the second chunk of JavaScript, which is written like this. This is the encrypted blob of thing. This does the decryption here. So anyway, the value of next key is what was actually stuffed into the URL on the other slide, and it's publicly known. And so it looks like, if you're just looking at this code by itself, you say, hey, wait a second, I know the value of next key that was speeded on the wire. And it would be, you'd think it'd be like a horrible crypto mistake if they just revealed all their secret keys in doing this. But it turns out that RC4 decrypt in the lucky exploit thing actually takes the 53-byte nonce from the originally and adds it in, concatenates it in. So you end up getting a key like this for the RC4 value, and it doesn't have any more entropy than the original key did, since the public key that transforms that into that is known. But well, actually, you don't know the nonce. Sorry, never mind. And this is how it comes back. Checks for Flash version and so forth. So the other thing that's been using a lot of crypto lately is ransomware, which is sort of been a growing trend lately. It's been around for a really long time. There's actually I've seen like a couple of press reports going on about how this is brand new, and no, it's not. I've heard about this back in the 1980s. There was actually a Dick Tracy comic in the newspapers back in like 1989 that went through this whole scam, basically. So currently the only family of ransomware that's doing the CryptGenKey is GP code, and actually the early versions didn't. They had their own home-rolled crypto that was trivial to crack. So in the current versions, they use the Windows Crypto API, and it basically does the CryptWrite. So my mic's flying off my head again. Excuse me. So basically, what the ransomware does is it searches your disk for all your documents, encrypts them all with a random RC4 key, takes a random RC4 key, encrypts it with RSA with the attacker's or the extortionist's public key, and stores that on a file and says, if you want your files back, send this value back to this address. And the attacker then goes and encrypts it, gets the session key, stuffs it in the executable file, and sends the executable back to them. The bot will like delete it, clean up after itself. But this is pretty much, it's a pretty short program. This is pretty much all. The bulk of it is just calling these functions here. So you get it drops a message like this. For this particular variant, it would pop up an alert box for it. Yeah, I haven't changed anything. It really does say to recover your files. But this is another example. A lot of these seem to be Russian in origin. So there's a lot of bad crypto floating around because I know people, because this stuff isn't written by computer scientists, and I don't know, for your own reason, there's probably a lot. But if you're reversing, usually the quick way to find crypto, a lot of people, all they do is basically just repeatedly XOR some constant value. It's like the first crypto system everyone invents is like, they hear about one-time pad and they're like, oh my god, I'll create this great one-time pad system that uses the pad multiple times. And so everyone makes this mistake first. And so usually if you just disassemble the entire program, search for all the XOR operations, and then throw away, then grep out all of the XOR operations where the source and destination register are the same, you'll generally get like 5 XORs, and they'll generally at least one or two of them will be the crypto routine. So it's the quick way to do it. Otherwise, just tracing back and forth from the FileRead and FileWrite operations and send and receive stuff is will do it, because generally as soon as something is read, the next function called is the decryption routine. So an example of bad crypto ransomware was the VS-Crypt Trojan. The author apparently called it Trojan encoder in Russian, but it was carried on a